Good morning students, welcome to my video lecture. First Brahmanath. Om Shanti Shanti Shanti. In last class we discussed modulus function and greatest integer function, their properties, also their graphs. Okay, again recall that functions once again. Modulus function are also called absolute valued function. This is f of x is equal to mod x, and mod of x always gives non-negative value. Non-negative value. Domain of this function is set of real number r, and range of function is equal to 0 to infinity. 0 included, semi-close, semi-open, 0 to infinity. Domain of f real number r, range of f 0 to infinity. This is absolute valued function. F of x is equal to mod x. Mod x is equal to x when x greater than 0 and minus x when x less than 0, 0 when x is equal to 0. This is mod x. Next one, greatest integer function. Greatest integer function, f of x is equal to square bracket x. So square bracket x always gives integral value. Square bracket x always gives integral value. Therefore domain of the function is real number r, and range of the function is set of integer z. Okay, when x lies between two consecutive integer, we choose lower one. When x lies between 1 and 2, the square bracket of x is equal to 1. When x lies between 2 and 3, the square bracket of x is equal to 2. Okay, so this is also called step function. Next, least integer function. Least integer function means f of x is equal to, same way f of x is equal to this type. This is the least integer function. This is not, this is wrong, means least is denoted by this type, not this type. Hala, I answer kardeythili, tame eta answer karibo. Least integer function, hala, and f of 0.1 ର least integer is equal to 1. Means when x lies between two consecutive integer, we choose upper one. In case of greatest integer, we choose the lower one. In case of least integer, we choose greater one. Okay, so greater integer means 0.1 lies between 0 and 1. So least integer of 0.1 is 1. Okay, so domain of this function also real number and range is set of integer z. Today we are going to discuss some other functions. One signum function. Signum function. Signum function. A function f from r to r. A function f such that r to r is said to be a signum function. Signum function if f of x is equal to xgn x is equal to mod x by x comma x not is equal to 0 and 0 when x is equal to 0. Also is equal to 1 when x is greater than 0, 0 when x is equal to 0, minus 1 when x is less than 0. Mod of x is equal to x when x is greater than 0, so x is cancel, it is 1. Mod of x is equal to minus x when x is less than 0, so minus x by plus x is equal to minus 1. Okay, so when x is greater than 0, it is 1, when x is equal to 0, it is 0, and when x is less than 0, it is minus 1. So always gives 3 values only, 3 values, 1, 0, minus 1. Okay, so example SGN 10 is equal to 1 because 10 is greater than 0. SGN 0.00001 is equal to 1 because 0.0001 greater than 0. SGN 0 is equal to 0. SGN root 2 is equal to 1 because root 2 is greater than 0. SGN minus pi is equal to minus 1 because minus pi is less than 0. Okay, therefore domain of f is equal to, domain of this function is equal to real number r, because x is, we can take x is positive value, x is negative value, also x is equal to 0. So domain of f is equal to real number r, but range of signum function, the range of signum function only 3 values, minus 1 or 0 or 1. This is curly bracket. Okay, means आम कौन पाइबा सब minus 1 0 1 ये 3 value ही पाइबो. Signum function of negative value એટલે minus 1, signum function of positive value is plus 1, and signum function of 0 is 0. Okay, so always we get 3 values only, 3 output only. One is minus 1, 0 and 1. This is called a signum function. And the graph, देखो graph देखो ठीक. This is x axis, this is y axis, this is origin 0 1. This is 0 minus 1. When x is equal to 0, output is 0, means SGN 0 is 0. When x is greater than 0, so output is 1. Okay, देखो तो 1 1 1 means when x is equal to 0.1 1, when x is equal to 0.2, SGN is 0.2 is 1. When x is equal to 1, SGN 1 is 1, SGN 2 is 1, SGN 3 is 1, SGN 10 is 1, and so on. Similarly, SGN of minus value is minus 1, but SGN of 0 is 0. Okay, so this is the signum function. F of y is equal to SGN x. Okay, here I am going to signum function. Next one, characteristic function or indicator function. Characteristic function or indicator function. Characteristic function or indicator function. Let R be a set of real number and capital A is subset of R, and capital A is a subset of R. Then the function f such that R to R is said to be an indicator function, if f of x is equal to 1 when x belongs to set A and 0 when x does not belong to set A. 1 when x belongs to A and 0 when x does not belong to set A. or x belongs to r minus a. Okay, it is denoted by chi of x base a. Chi of x, chi of x base a. This is called chi of x base a. When x belongs to set a, it is 1. When x does not belong to set a, it is 0. For example, let a is equal to, this is 0 to 10, suppose. Then f of 0, it is 1. F of 0.5, it is 1. F of 10, it is 1. F of 11, it is 0, because 11 does not belongs to 0 to 10. Okay, f of minus 0.001, 0, because minus 0.001 does not belong to 0 to 10. 0 to 10. Okay, so when x belongs to set a, then the value of the function is 1. When x does not belong to set a, it is 0. This is called indicator function. Okay, or characteristic function. Next one, step function. Step function means, suppose R be a set of real numbers, and the set of real number is subdivided into some subset of R, and each subset of R are disjoint subset of R, means they are mutually disjoint, they have no common element among them, mutually disjoint. So the output of this function is constant in each subinterval of the R. Output of this function is constant in each subinterval. Okay, so let the interval is, let R, step function, step. Let the interval be divided into different subinterval. Let the interval is divided into different subinterval. Different subinterval of the domain is called the partition. Of the domain is called the partition of R. Okay, a function f from R to R is said to be step function. A function f such that R to R is said to be a step function. If the value of the function is constant in different interval. Step function if the value of the function is constant in different subinterval. This is set of real number R, minus infinity to plus infinity. Okay, so R is equal to what? Minus infinity to plus infinity. Suppose R we divide into 3 sub-intervals. Suppose this is minus 100, this is 50, this is one interval, this is one interval, this is one interval. All are mutually discharged. Means they have no common element between them. Means आ भीतर कॉमन किछ नहीं, आ सदार कॉमन किछ नहीं कि आ सदार कॉमन किछ नहीं. तो से कौन कहती mutually disjoint. Okay, so this is called partition. Partition of a set means a set is divided into some parts or some subsets. They have no common elements. Means they are mutually disjoint. Okay. So is equal to minus infinite to minus 100 union minus 100 to 50 union 50 to infinity. So they are sub-interval of real number R. Sub-interval of real number R, and this is called 1-1 partition. This is called 1-1 partition. So f of x is equal to, this is 10. 10 is a constant, any constant, you may write any constant. When x belongs to this interval, minus infinite to minus 100. Another one, minus 50, when x belongs to this interval, minus 100 to 50. Next, 0, when x belongs to this interval, 50 to infinity. This is called step function. This is called step function. Means in different interval, the value of the function is constant. The value of the function is constant. Okay. So you can write also this is 50 to 75 union 75 to 100 union 100 to infinity. So this is another one. 2 when x belongs to 75 to 100 and root 2 when x belongs to 100 to infinity. Okay. So in different sub interval of the function of the set R, the value of the function is constant. Okay. So domain is equal to set of real number R. Domain is equal to real number R. Range is constant. Range is constant. Okay. Therefore greatest integer function is a step function. Also least integer function also a step function. Indicator function also a step function. Means indicator function is a step function, but the converse may or may not be true. Least integer function is a step function, but the converse may or may not be true. Greatest integer function also step function, but the converse may or may not be true. Okay. Next one, remainder function. Remainder function. Okay. Let n be a positive integer and m be any integer, this is m कर दिया, this is m. Let m be a positive integer and n be any integer, that is n belongs to z. We define Rn base m as the remainder obtained by remainder obtained by divide by remainder obtained by dividing n n by m, dividing n by m. Okay, that is 0 less than is equal to r less than m. Less than m means remainder always greater than or equal to 0 and less than divisor. Okay, less than divisor. Okay, so Rnm is unique. Rn base m, Rn base m is unique number such that n is equal to mq plus r. n is equal to mq plus r. Okay, so 0 less than is equal to r less than m, and q also q is quotient belongs to set of integer z. q belongs to z. That means n को डिवाइड कला कह द्वारा m द्वारा, तो ये आसला q, तो ये है mq माइनस कर लो, तो ये है कौन तुम रिमाइंडर r. तो r is always less than m strictly, r is less than strictly m and greater than is equal to 0. So it is called remainder function. For example, find r if r, this is 7, this is 24. तो 24 को डिवाइड करो 7 द्वारा, तो 7 3 जा 21, तो माइनस करो कौन 3. तो द वैल्यू ऑफ दिस, तो आंसर कौन आसो कहला, आंसर r24 7 is equal to 3. Okay, another example, find r if r minus 50 base 7. तो माइनस 50 बेस 7 आंसर. तो माइनस 50 को डिवाइड करो 7 द्वारा, तो 7 जा, तो 7 माइनस 8 जा माइनस 56, तो प्लस, तो दिस इज 6. therefore r minus 50 base 7 is equal to 6. means remainder always greater than 0. this is wrong. If we put minus 50 divided by 7 द्वारा minus 7 and minus 49, this is minus 1, it is wrong because this is less than 0. Okay, if the remainder is negative, this is remainder never negative, the remainder always greater than is equal to 0, hence the remainder not is equal to minus 1. So in this case we can use another method, minus 1 plus divisor, add this minus 1 plus 7 is equal to what? 6. So 6 is the remainder. Okay, this is called remainder function. Next one, exponential function. Exponential function. Let a is a positive number positive real number other than 1 को छाड़ी let a be a positive real number, a be a positive real number other than 1. Let the function a function f from R to R, a function f such that R to R is said to be an exponential function if y is equal to f of x is equal to a to power x, condition a greater than 0, a not is equal to 1. Okay, x belongs to R. This is the exponential function. Okay, so domain of this function, domain is equal to set of real number R, because for every real value of x, y is finite value, so domain is equal to real number R, and range of f is equal to 0 to infinity, only positive value R plus, means for every value of x, a to power x is always greater than 0, because a to power x is greater than 0 for all x belongs to R. Okay, when a greater than 1, then a to power x is an increasing function. Example, let y is equal to 2 to power x. So here a is equal to 2 greater than 1. So x is equal to 1, y is equal to 2, x is equal to 2, y is equal to 2 square, that means 4. Therefore, as 1 less than 2 implies 2 also less than 4. Small input, small output, higher input, higher output. This implies a to power x is an increasing function. Okay, तो ग्राफ देखो, ये ग्राफ देखो, दिस इज x, दिस इज y ओरिजिन. तो ये ला y is equal to 2 to power x, y is equal to 3 to power x, y is equal to 4 to power x. Same type x, y. X is equal to 0, y is 1, x is 1, y is 2, x is 2, y is 4, x is minus 1, y is 1 by 2, x is minus 2, y is 1 by 4. Similar next, y equal to 3 to power x कैसे है? x, y. X is 0, y is 3 to power 0 means 1, x is 1, y is 3, x is 2, y is 9, minus 1, 1 by 3, minus 2, 1 by 9. Next case, x, y, 4 to power x कैसे है? 0, 4 to 0 means 1, 1, 4, 2, 16, minus 1, 1 by 4, minus 2, 1 by 16. No negative value. When x is positive, y is positive. When x is negative, y also positive. Okay, तो देखो This is 0, 1. Y is equal to 2 to power x. Next, y is equal to 3 to power x. Next, y is equal to 4 to power x. X is equal to 0, y is equal to 1. X is equal to 0, y is equal to 1. X is equal to 0, y is equal to 1. Means at 0, 1, all curves are going to coincide. When x is equal to 1, y equal to 2. X is equal to 1, y equal to 2. Next 3, next 4. X equal to 2, y is equal to 4. Then 9, then 16, and so on. This is exponential function. Exponential function when a greater than 1. A is greater than, this is a is greater than 1. A is greater than 1. So a is greater than 1, curve is like this. It is parallel to, means asta coming on parallel to x-axis. X-axis, y-axis, y is equal to a to power x, comma a greater than 1. Now y is equal to e to power x, same type graph. Y is equal to e to power x, so 2 less than e less than 3. So since e greater than 1, so like this, graph is also like this. And this is 0, 1. When x is 0, y is 1. Okay? When a lies between 0 and 1. When 0 less than a less than 1. So y is equal to a to power x is a decreasing function. Is a decreasing function. Example, let a is equal to 1 by 2. A is equal to 1 by 2. So y is equal to 1 by 2 to power x. X is equal to 0, y is equal to 1. X is equal to 1, y is equal to half. X is equal to 2, y is equal to 1 by 4. This implies 1 is less than 2, but 1 by 2 is greater than 1 by 4. So less greater means small input, higher output. Higher input, low output, lower output. छोटा इनपुट बड़ा आउटपुट, बड़ा इनपुट छोटा आउटपुट. तो इट इज ए कौन डिक्रीजिंग फंक्शन. इट इज ए डिक्रीजिंग फंक्शन. ओके, तो ग्राफ देखो टिके x, दिस इज y, दिस इज 0, 1. तो ये ला y इज इक्वल टू 2 टू पावर x, y इज इक्वल टू 3 टू पावर x, y इज इक्वल टू 1 by 2 to power x, 1 by 3 to power x, 1 by 4 to power x. Okay, so x, y, x0, y1, x1, y half, x2, y1 by 4, x minus 1, y2, x minus 2, y4. When x approaches to infinity, y tends to 0. When x approaches to infinity, y tends to 0. When x approaches to minus infinity, y tends to plus infinity. Okay, तो ये विषय है 0, 1, 1 by 3, 2, 1 by 9, minus 1, 3, minus 2, 9. 0, 1, 1 by 4, 2, 1 by 16, minus 1, 4, minus 2, 16. देखा तो दिस टाइप आसो. This is 0, 1. So first one y is equal to 1 by 2 to power x, second one y is equal to 1 by 3 to power x, third one y is equal to 1 by 4 to power x. So here a lies between 0 and 1. A lies between 0 and 1. ओके तो ये आमर एक्सपोनेंशियल फंक्शन व्हेन दिस टाइप y is equal to a to power x 0 less than a less than 1. This value is 0 comma 1 x, this is y. When x approaches to infinity, y tends to 0. When x approaches to minus infinity, y tends to plus infinity. Okay, एतले एक्सटा प्लस आड़ को कौन करुँची अप्रोच करुँची y ର वैल्यूटा कमी 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 0 आड़ को जाऊँगी. When x approaches to minus infinity, y approaches to infinity. Okay, so properties. Properties of exponential function. Properties of exponential function. Okay, 1. a to power m into a to power n is equal to a to power m plus n. 2. a to power m by a to power m is equal to a to power m minus n. a to power m whole to power n, a to power mn, a to power mn. 4. a to power x is equal to infinity, a to the infinity is equal to infinity if a greater than 1, 0 if a is less than a lies between 0 less than a less than 1. Okay, next 5. a to power minus infinity example नहीं पारो example a is equal to 3 let so 3 to power infinity 3 to infinity is equal to infinity 3 to power minus infinity is equal to 1 by 3 to infinity is equal to 1 by infinity tends to 0. Okay, नहीं 1 by 3 to infinity तो here a is equal to 1 by 3, a is equal to 1 by 3, 1 by 3 to infinity is equal to 1 by infinity tends to 0. Next 5. a to the minus infinity is equal to 0 if a greater than 1 and infinity if 0 less than a less than 1. So these are the properties of exponential function. Okay, next one logarithm function. Logarithm function just opposite of exponential function, logarithm. Function. Okay, logarithmic THMIC logarithmic function. The function I have defined, the function f defined as the function f defined as f of x is equal to log of x base a, log of x base a. Condition x greater than 0, strictly x greater than 0 and a also greater than 0 but a not is equal to 1. a also greater than 0 but a not is equal to 1. Okay, so x is strictly greater than 0, therefore domain of f is 0 to infinity. 0 to infinity means r plus. Okay, range of f real number r means for all positive as well as negative value. Range of f both positive and कौन आसो आमर negative, ये range of f. log x base a, log x base a. Okay, note मन रख दीजिए, note let y is equal to log of x base a, y is equal to log of x base a, double implies x is equal to a to power y, a to power y. Y is equal to log x base a, then x is equal to a to power y. Okay, example, y is equal to let y is equal to log of x base 2. So this implies x is equal to 2 to power y. Okay, x is equal to 2 to power y. Similarly, y is equal to log of x base 10. So x is equal to 10 to power y. So they are opposite to each other. So very important. Okay, so our domain, their range, our range, their domain. So domain of exponential function is this, range of logarithm function, and range of exponential function is equal to domain of logarithm function. So they are opposite to each other. They are opposite to each other. Okay. So domain of logarithm function is equal to range of exponential function hala, and range of logarithm function is equal to domain of exponential function. Okay, and vice versa. Okay, ग्राफ देखा टिकिए, ग्राफ y is equal to log of x base a. So here a greater than 0, another one y is equal to log of x base a, 0 less than a less than 1. Okay, x greater than 0, in both cases x greater than 0. In both cases x greater than 0. This is x, this is y. Okay, so here x positive means the curve lies in first and fourth quadrant. Because x positive means which quadrant? First and fourth quadrant. Okay, so this is like this. This is 1, 0 when log of 1 base a is equal to 0. So log 1. This is y is equal to log x base a greater than 1. Okay, origin. This is just volta x y. This is like this. This also 1, 0, but volta. Okay, तो ये है हमारा इंक्रीजिंग फंक्शन. ओके, तो ये हमारा when a greater than 0, this is y is equal to a to y is equal to log of x base a, condition 0 less than a less than 1. ओके, ये ला ग्राफ ऑफ लॉगरिथम फंक्शन. एटा मिसियोनी, एटा मिसियर नाही. कौन हम पैरेलल हम, पैरेलल कोटले कोइंसिड करियोनी, पैरेलल. ओके, नेक्स्ट प्रॉपर्टीज ऑफ लॉगरिथम फंक्शन. प्रॉपर्टीज ऑफ लॉगरिथम फंक्शन. logarithmic function, properties of logarithmic function. Okay, properties of logarithmic function. Okay, 1 log of a base a is equal to 1. Log of a base a is equal to 1. 2. Log of 1 base a is equal to 0. 3. Log of 0 base a is equal to minus infinity. 4. In all cases a greater than 0. Hello? Log of infinity base a is equal to infinity, a greater than 1. 5. Log of m to power n is equal to n log m. Base जहाँ रोज ना रहो. 6. Log of m into n into p is equal to log m plus log n plus log p. 7. Log of m by n is equal to log of m minus log of n. Log of m minus log of n. 8. Log of fx base gx. तो fx should be greater than 0 and gx also greater than 0, but g of x not is equal to 1. G of x not is equal to 1. Okay. 9. Log m base n is equal to log of m base a divided by log of n base a, or you may take log of m base 10 by log of n base 10, or any real number, but any positive real number, but not equal to 1. Okay, so a may be a is any positive real number, but not is equal to 1. Next, 10. Log m to power n base a to power b is equal to n by b log of m base a. Log of m base a. 11. Log of x base 10 is called common logarithm. Is called common, jar base 10 अछि, common logarithm. Okay. 12. Log of x base e is called natural logarithm. Okay, and is denoted as lnx. जरा बेस्ट ई तक आम ln कहती, तो e 2 is less than e less than 3 means that is e is equal to 2.716 ... This is an irrational number. Okay, irrational number. So these are the properties of logarithmic function. Okay. Next, 13. A to power m log fx base a is equal to fx to power m. Example, 2 to power 5 log x base 2. जदि समान थिया पड़ो a को a 2 को 2, तो इज इक्वल टू x to power 5. E to power 3 ln x means x cube, because ln means base e. 14. Log of e to power fx base e is equal to fx. So these are the properties of logarithm. Okay, so main use of logarithm means to to find the value of a complex function, to find the value of a complex function using logarithm means गोटे कम्प्लेक्स फंक्शन दिखाई तार भैल्यू बाहर बहुत कष्ट डिफिकल्ट तो से केस आम कौन लग यूज करवा तो आम इजी हम टे लग यूज कर भैल्यू बाहर करने तो लॉगरिथम टेबल अच्छी तो आम टेबल यूज आम भैल्यू बाहर कर तो लॉगरिथम की टेबल देखिए तुम प्रैक्टिकल नोटबुक अच्छे आम प्रैक्टिकल जो फिजिक्स केमिस्ट्री प्रैक्टिकल नोटबुक अच्छी तार पछकानी मीन्स लास्ट पेज तो अच्छी लॉगरिथम की टेबल ओके नेक्स्ट वन even and odd function a function f of x is called an odd function if f of minus x is equal to minus fx for all x belongs to domain of f for all x belongs to domain of f means x जगह माइनस एक्स सब्स्टिट्यूट करवा यदि माइनस एफ एक्स आसीगला तो फंक्शन को आम कौन कहवा ऑड फंक्शन ओके तो एग्जांपल नहीं पारिया आम let f of x is equal to s cube minus sin x okay तो f of minus x whole cube minus sin of minus x equal to this is minus s cube this is minus plus sin x because sin of minus x is equal to minus sin x तो taking a minus is common तो s cube minus sin x तो is equal to minus fx this is fx तो therefore f of x is an odd function तो x जगह माइनस एक्स पुट करवा तो माइनस एफ एक्स आसीगला तो फंक्शन कौन कह ऑड फंक्शन ओके नेक्स्ट वन इवन फंक्शन a function f of x is said to be an even function if f of minus x is equal to plus fx f of minus x is equal to plus fx for all x belongs to domain of f for all x belongs to domain of f example let f of x is equal to x into e to power x plus e to power minus x divided by or x into sin x plus 5 cos x this is fx तो f of minus x is equal to minus x sin minus x plus 5 cos of minus x is equal to minus x this is minus sin x because sin of minus 3 is minus sin theta plus 5 cos x because cos of minus 3 is plus cos theta is equal to x sin x plus 5 cos x is equal to fx is equal to what fx so this implies fx is even function implies f of x is an even function okay cos of minus x is equal to plus cos x cos of minus x is equal to what plus cos x okay test find the nature of the following functions nature means हम चेक करिबा इवन आ कोन ऑड कोडा ऑड फंक्शन कोडा इवन फंक्शन ओके तो आंसर देख टिए 1 given f of x is equal to log 2 minus x divided by 2 plus x बेस जहाँ दो दियो ए ओके तो एफ ऑफ माइनस एक्स जगह माइनस एक्स पुट करो तो लॉग बेस ए दिस इज 2 प्लस एक्स डिवाइड बाई 2 माइनस एक्स जगह माइनस एक्स पुट कराला ऐसे कौन पड़ा माइनस एक्स इज इक्वल टू लॉग बेस ए दिस इज 1 बाई 2 माइनस एक्स डिवाइड बाई 2 प्लस एक्स वी कैन राइट दिस ओके तो ये ऊपर चल जाइए तो इज इक्वल टू log of m by n, this is log 1 base a minus log of 2 minus x by 2 plus x base a. log 1 is 0, so 0 minus fx, so 0 minus fx, so f of minus x equal to minus fx, so this implies f is odd function, implies f of x is an odd function, okay. f of x is an odd function. Next, second one, given f of x is equal to log of x plus square root of 1 plus x square. So put x equal to minus x. So log of this is minus x plus root 1 plus minus x whole square is equal to log of minus x plus root 1 plus x square is equal to log of this is 1 plus x square root minus x is equal to log this is root 1 plus x square minus x into root 1 plus x square plus x divided by root 1 plus x square 1 plus x square plus x means rationalize कर दिया, rationalize प्लस रे मल्टीप्लाई करा डिवाइड करा तो इज इक्वल टू लॉग a माइनस बी इंटू a प्लस बी तो a स्क्वायर माइनस बी स्क्वायर तो 1 प्लस एक्स स्क्वायर माइनस एक्स स्क्वायर बाय रूट 1 प्लस एक्स स्क्वायर प्लस एक्स स्क्वायर एक्स कैंसिल दिस इज लॉग ऑफ 1 बाय रूट 1 प्लस एक्स स्क्वायर प्लस एक्स तो लॉग m बाय n लॉग m माइनस log m minus what log n this is log of 1 minus log of x plus root 1 plus x square okay so this is 0 minus fx so implies fx is an odd function fx is an odd function okay fx is an odd function next third one 3 f of x is equal to x by 2 to x plus 1 minus x by 2 plus 1 so f of minus x by 2 to power minus x plus 1 this is minus of minus x by 2 plus 1 so is equal to minus x by 1 by 2 to power x plus 1 1 by 2 to power x plus 1 plus x by 2 plus 1 तो is equal implies f of minus x is equal to minus x by 2 to 1 plus 2 to x divided by 2 to x this is x by 2 so this is plus x minus x by 2 plus x by 2 is equal to x minus x by 2 plus 1 so is equal to minus x into 2 to x divided by 2 to x plus 1 चल ऊपर को plus x minus x by 2 plus 1 find LCM 2 to x plus 1 minus x into 2 to x plus multiply this x into 2 to x plus x minus x by 2 plus 1 ये cancel तो x divided by 2 to x plus 1 minus x by 2 plus 1 is equal to plus fx this implies f of x is an even function f of x is an even function okay and last one this is homework for you okay next any function can uniquely expressed theorem any function can uniquely expressed as the sum of even and odd function okay proof देख यार proof let f of x is any function therefore we can write f of x is equal to 2 into f of x divided by 2 that is fx plus fx divided by 2 or we can write f of x plus f of minus x plus f of x minus f of minus x whole divided by 2 means add f of minus x and subtract f of minus x okay the value does not change is equal to f of x plus f of minus x by 2 plus f of x minus f of minus x by 2. Suppose this is g of x and this is h of x. So now g of minus x is equal to f of minus x plus f of minus x means plus fx by 2 is equal to gx. So implies gx is even. Next, h of minus x, f of minus x minus f of plus x divided by 2. So taking minus is a common, f of x minus f of minus x divided by 2 is equal to minus hx. This implies hx is odd. hx is odd. So this is even, this is odd. That means this is even plus odd. So any function or every function can uniquely, every function not every function can uniquely express as the sum of even and odd function. Sum of even and odd function. Okay. Example, express the function f of x is equal to sin x plus e to power x as sum of even and odd function. Answer given f of x is equal to sin x plus e to power x. So find f of minus x. So sin of minus x plus e to power minus x. This is minus sin x plus e to power minus x. Okay. So let g of x is equal to fx plus f of minus x by 2. So is equal to sin x plus e to power x. This is fx minus sin x plus e to power minus x divided by 2. Cancel. This is e to power x plus e to power minus x by 2. So this is equal to g of minus x. It is an even function. Let hx is equal to fx minus f of minus x by 2. So sin x plus e to power x fx minus of minus sin x plus e to power minus x divided by 2. Okay. So is equal to 2 sin x plus e to power x minus e to power minus x whole divided by 2. तो check करो h of minus x is equal to 2 into sin minus x plus e to power minus x minus e to power plus x whole divided by 2. This is minus 2 sin x plus e to power minus x minus e to power minus x divided by 2. So taking minus is a common. So 2 sin x. This is minus 2 sin x. This is e to power x plus, this is plus. So plus e to power x minus e to power minus x divided by 2 is equal to minus hx. This implies h of x is odd. Therefore, f of x is equal to gx plus hx. F of x is equal to gx plus hx. That implies f of x is equal to what is gx? G of x is equal to e to power x plus e to power minus x by 2 plus hx. hx is equal to 2 sin x plus e to power x minus e to power minus x by 2. This is odd function. This is odd. So this is even plus odd. So any function can uniquely express a sum of even and odd function. Okay. Okay. Note मन रखो टिके note 1 sum of two even function is even, sum of two odd function is odd, product of two even function is even, product of two odd function is odd, product of odd and even is odd. So this is even. The odd product of two odd function is even, but product of odd and even odd means plus into plus is equal to plus, minus into minus is equal to plus, but plus into minus is equal to minus. Okay, so these are the some properties of odd and even function. Okay, in next class we shall do trigonometry function and their graphs, also periodic functions. Okay.